Let us discuss the first property. Property 1. Sine inverse of sine theta is equal to theta. This is the first and foremost property, and the condition here is theta lies between minus pi by 2, that is pi by 2 minus pi by 2 is less than or equal to theta, and that is less than or equal to pi by 2. Under this condition, it means a closed interval, so it can be interpreted as, that is, theta lies between the closed interval minus pi by 2 and plus pi by 2. Second, cos inverse of cos theta is equal to theta. Again, here we need to give the condition, that is 0 is less than or equal to theta, which is less than or equal to pi in the case of cos. Then third one, tan inverse of tan theta is equal to theta, provided minus pi by 2 is less than theta, which is less than pi by 2. So in this case, this is an open interval, that is, it lies between minus pi by 2 and pi by 2, but we need to put the open interval. Then fourth one, tan inverse we have completed, and what is the reciprocal of tan? Cot. So cot inverse of cot theta is equal to theta, provided 0 is less than theta, that is less than pi. It means it's an open interval, that you know. Okay. Then 5, secant. Secant is the reciprocal of cosecant, is it not? So secant reciprocal of cos. So secant inverse of secant theta, that is equal to theta again, and here 0 is less than or equal to theta, as well it is less than pi by 2, or you can say pi by 2 is less than theta, that is less than or equal to pi. Then sixth one, cosecant inverse of cosecant theta, that is equal to theta, provided minus pi by 2 is less than or equal to theta, and that is less than 0, or 0 is less than theta, that is less than or equal to pi by 2. Okay, so you have to memorize all these 6 important equations that under the property 1. Okay. Let us look at the second property. Here, sine of sine inverse x is equal to x. In the previous case we discussed sine inverse of sine theta is equal to theta, and here sine of sine inverse of x is equal to x, and here the condition is -1 is less than or equal to x, and that is less than or equal to 1. And 2, cos of cos inverse x, that is also equal to x, provided -1 is less than or equal to x, and that is less than or equal to 1. Third one, tan inverse of x, that is equal to x, provided that minus infinity is less than x, that is less than infinity. Then cot inverse x is equal to x, provided minus infinity is less than x, that is less than infinity. And then secant inverse x is also equal to x, provided minus infinity is less than x, that is less than or equal to -1, or 1 is less than or equal to x, that is less than infinity. Then what is the reciprocal of sine? Cosecant. So cosecant inverse of x is equal to x, provided minus infinity is less than x, that is less than or equal to -1, or 1 is less than or equal to x, that is less than infinity. Right? Let us move to the third property. Property 3. Sine inverse of minus x is equal to minus of sine inverse x for all. So this symbol represents for all. X belongs to, that is the closed interval, -1, 1. Okay, so it means -1 is less than x, and that is less than or equal to x, and that is less than or equal to 1. So that can be represented in this way also. Similarly, cos inverse of minus x, that is given by pi minus cos inverse of x. So for all x that belongs to, that is the interval -1, closed interval -1, 1. Then 3, tan inverse of minus x is equal to minus tan inverse of x for all x belonging to the, it can be a real number, so you can put simply a real number. So x belongs to R, right? Then fourth, let us consider cot inverse. Cot inverse of minus x is equal to pi minus cot inverse of x for all x that belonging to or the real number r. Then 5. Secant inverse of minus x is given by minus secant of inverse of x for all x belongs to open interval minus infinity and minus 1 closed interval here. What do you mean by that? That is, minus infinity is less than x, less than x, and x is less than or equal to minus 1. So on the right side it is closed, on the left side it is open. And union, so union, again you can put the closed interval, you have to do it carefully, 1 comma infinity open interval. Okay, so it can belong to both, that is the union of these two sets. Then 6th, cosecant inverse of minus x is equal to minus cosecant inverse of x for all, similarly x belongs to minus open interval minus infinity, do it carefully, comma minus 1 closed interval union, then closed interval again 1 comma infinity, here open interval. Okay, right. So this is with regard to property 3. Let us look at the 4th property. Sine inverse of x plus cos inverse of x is given by pi by 2 for all x that belongs to open interval minus 1 comma 1 closed interval. 2. Tan inverse of x plus cot inverse of x is given by the same pi by 2, and here for all x that belongs to the real number. 3. Secant inverse of x plus cosecant inverse of x is also given by pi by 2 for all x that belongs to open interval minus infinity closed interval minus 1 union closed interval 1 comma and then infinity open interval, right? Then let us move to property 5. Property 5. Here sine inverse of x is equal to cosecant inverse of the reciprocal of x, that is 1 by x, whereas x belongs to open interval minus 1 comma 1, closed interval, and then that is approximately here, that is the 0, and x that is, we can say cosecant inverse of x also, and can put cosecant inverse of x is equal to sine inverse of 1 by x. Now in this case x belongs to open interval. Here this is open interval, minus infinity comma minus 1 closed interval union open interval 1 comma infinity, and then open interval, closed interval, open interval. Then second set, cos inverse of x can be secant inverse of 1 by x, and the condition here is x belongs to the closed interval minus 1 comma 1, and that can be approximated to closed interval, that is except this is 0. So and let us say secant here, secant inverse of x is equal to, can you guess, which is nothing but cos inverse of 1 by x, right? Now x belongs to minus open interval minus infinity comma minus 1 closed interval union closed interval 1 comma infinity open interval, right? Here you should note one important aspect, that is, when we say x belongs to between the closed interval minus 1 and 1, you may ask whether 0 can be included. No. So this indicates the negation, that is not included, that is excluding 0. Similarly here minus 1 1 means that is excluding 0. Okay, right. Then third one, tan inverse of x is equal to cot inverse of the reciprocal of x, such that x belongs to 0 comma infinity between the open interval. Okay, so between the open interval of 0 and infinity, that is equal to minus pi plus cot inverse of 1 by x also, where x belongs to open interval minus infinity comma 0, right? Open interval. And similarly we can include cot inverse here of x can be what? Tan inverse of 1 by x. In this case x belongs to, that is open interval 0 comma infinity open interval, that is equal to plus pi here. So pi plus tan inverse of 1 by x, where x belongs to what? That is open interval minus infinity comma 0 open interval. Okay, so all these 5 properties are very, very important. We will proceed with the other properties in the next session. Thank you for watching this concept.